Hello all, this is the video review guide for Units J and Unit K. Unit J deals with thermochemistry in solutions, and acids and bases is Unit K. So here are the details about the test. You should review this. If you are coming back to this video, this link works now. Previously, I'm sorry if you got rickrolled. I just had not finished the answer key yet. So here we go. This is the info that you will get on the day of the test. You should use your textbook or other sources to define some of these terms. And then the problems begin on the next page. So question 2 is about a combustion reaction. This is ethanol, and if you burn it, the change in enthalpy is a decrease by 1,368 kilojoules for every mole of ethanol that you have. So because delta H is negative, this reaction is exothermic. If you did it, it would give off energy. I hope this makes sense, because if you burn stuff, you can feel it getting warmer. The energy is coming out of the reaction and going into the surroundings. So if the delta H is negative, then the reaction is exothermic. The next question asks, if you burned 1 mole, how much energy would you release? Well, that's what enthalpy change is reported in. It's reported in kilojoules per mole. So if you burned a mole, that's the amount of energy. Question D gives you a different amount. This is not a mole. This is less than a mole. 11.75 grams of ethanol. If you change it into moles, you need the molar mass. It's possible I made a mistake on the molar mass. I did this in my head quickly, but regardless, take the mass that's given, change it into moles, and then use the enthalpy change to determine the amount of energy for that amount. So if you have about 1/4 of a mole, you're going to have about 1/4 of the energy released. The next question is a calorimetry question. This is the kind of question where if you take a hot metal and put it in water, you got to keep track of the two separate things. You got to keep track of the mass of the water separate from the mass of the metal. You got to keep track of the specific heat for water separate from the specific heat of the metal. And then the temperature change is different for each one, even though the temperature ends at the same point. So like these temperature final for both of them should be the same. How much they change by is different for each substance. If you have a calorimetry question, then you can use Q equals MC delta T. And because we have all of the information we need for water, you should use the mass of water, the specific heat of water, and the change in temperature for the water. If you do that, then the calculation for amount of energy is about 3,600 joules. Now, if water gained 3,600 joules, then you know that the metal lost 3,600 joules because of the law of conservation of energy. If you consider the metal to be the system and the energy goes out of the metal and into the water, then however much energy the metal lost is equal to the amount of energy that the water gained. After you have determined the amount of energy gained by the water, you can identify which metal it is based on this property. Because specific heat is different for every material, if you can measure the energy change, then you can use that property to identify the metal. So since you know Q from the law of conservation of energy, the mass was given, and you know how much the temperature changed by, you can use Q divided by M times delta T to get C. Now the math gets to about 0.416, and the given value is 0.412. So even though it's not like exactly equal, it's by far the closest one. If you did a percent error calculation, you're off by like a 1,000th of a joule times per gram times degree Celsius. The final question on the review guide that deals with thermochemistry is understanding what a reaction pathway diagram looks like and which part of it represents which ideas. So the change in enthalpy is the amount of energy change for the system. So here's how much energy you start with. These are the reactants, so that's A. Here's how much energy you end with. So the energy went from here to here. It can't go straight from here to here, though. If you put barium in the atmosphere, it wouldn't react unless some energy was added. So C is the activation energy. All right, that's the end of the material on the review guide that deals with thermochemistry. The next part begins with acids and bases. So you should use your readings from CK12 to define some of these terms. And then the problems to begin talking about acids and bases begin on the next page. So you can pause this to review these if you'd like. A couple that I will talk about. I will plan to bring a demonstration to show electricity to class before the test. And hopefully we will talk about litmus paper on the lab. The rest of these are things that either you need to calculate or know from the notes that were given. The strong acids, there's only 7 of them. You should be able to write a dissociation reaction for each of them. So just understand, how do the strong acids split into their ions? Any dissociation reaction is the splitting of a compound into its ions. Okay, the next 3 questions all have an acid plus a base. And if you add an acid and if you add a strong acid and a strong base, you certainly always produce a salt and water. This type of reaction is called a neutralization reaction. I know that it is also, maybe you recognize it as a double replacement, but when you're dealing with acids and bases, you can classify it as a neutralization reaction. These calculations are going to be, you'll have to do some of these on the test. Basically, be sure that you understand how to use this little diagram. The diagram will be given on the test, but if the question asks for the concentration of hydrogen ions and gives you the concentration of hydroxide ions, you have to understand how to go from here to here. Now, this is a one-step direction. You just need to understand that because the idea is that water can split apart. It doesn't split apart very often, but it can. And so that number is called a constant. So that's the number that we always, we know that it's called the dissociation constant of water. Now, this number divided by the hydroxide ions will give you the hydrogen ions. And so that's the first 3 calculations. All of them do the same thing. You take this, you divide it by this to give you this number. A really tricky thing for students in this class is make sure that you enter these numbers into the calculator correctly. It's really frustrating when you set up the problem right, but you get the answer wrong because you don't know how to use scientific notation. So if that's a question you have, you should come see me before the exam. Questions 15 through 17 give you the pH and ask for hydrogen ions. So now you're starting here. So if it gives you pH and asks for this, then this is the question you need to use. So you take 10 to the negative pH power. So that's this idea. 10 to the negative 4.98 power would be about 1.05 times 10 to the negative 5th. If you're calculating concentration, you have to have the units. Molarity is the units for concentration, and so those are the units that need to be there. The calculation is the same for the other 2. You take 10 to the negative power of 9.33. The next set of questions asks you to determine the pH, and the first 3 questions give you the hydrogen ions. So if you're starting here, and it asks for pH, you use this equation. So you take the negative log of this number. For questions 21 through 23, it's all the same calculation, but this time they're giving you this number. So it actually doesn't matter. You're here. It's asking for pH. You got to go 2 steps no matter which way you go. So you can go from here to here by taking 1 times to the negative 14th and dividing it by the number. And then take the negative log of that number to get to pH. Or you can go the other way. Take this number, do the negative log of the hydroxide ions to get the POH, and then 14 minus the POH will give you the pH. If you do it both ways, you should get the same answer. So, again, you just need to be careful about typing it into your calculator correctly. The last set of questions asks you to determine the POH. And so POH is pretty easy to get to from pH. It's 14 minus this number. So both of those show that. And then each of these shows you like to go from here to here. That's a two-stepper. You get to go this way and then this way. Or this way and then this way. But then for the OH concentration, you just take the negative log of this number to get the POH. So going from whatever the value that's given to what it's asking for, using this diagram will be an important part of the test on Friday. Okay, the last question on this section deals with a neutralization reaction. So if you have an acid and a base, it always makes a salt and water. Okay, now, if you keep track of the concentrations and volumes that are used, because we know that when things are neutralized, the number of moles are equal, then you can use this equation to figure out how many moles was present. And if you know the number of moles in a volume, you can determine the concentration. So I tried to keep the color coding useful. And so for both of them, you're using the same formula, C equals N over V. And the number of moles of hydrochloric acid need to equal the number of moles of sodium hydroxide. If you rearrange the equation, you can see that it's concentration times volume will give you N, and concentration times volume equals N. So that means the concentration of this times volume has to equal the concentration of this times its volume. So CHCl VHCl equals CNaOH times VNaOH. And if you rearrange the equation to get to C all by itself, you can see that if you take the concentration of NaOH times the volume used, and just want to point out, these are in liters. Milliliters to liters is divided by 1,000. So concentration times volume divided by the volume of the other chemical will give you the final concentration. We probably should round it to 0.76 because this one has only two significant figures. But the concentration of hydrochloric acid should be about 0.76 molar. The last two ideas on this part of the review guide deals with this thing, which is called a titration curve. And if you understand what's happening in this titration curve, you'll be in good shape. So just understand, you're changing the volume. If you change the volume of NaOH and you measure the pH, you would be able to produce a little curve like this. This looks like it's measured probably with a pH probe. If there's a way for you to measure like the actual pH. I know we have been talking about indicators, but there are technology devices that can measure the pH of a solution at an instant. So as you add more NaOH, the pH doesn't jump up super high until you get to the equivalence point. Then there is this like super steep spike. And that's because like at this instant right here, you get a flip in which ion is more prevalent. So after this instant right here, the pH is now over 7. That means that you have more hydroxide ions than you had hydrogen ions. All right, the last question asks about indicators. Indicators are a reasonable topic to be asked about. I should have abbreviated bromothymol blue like this. This word is super long. Phenolphthalein, I know it's hard to spell. You can use PPT. If you're talking about phenolphthalein, you can abbreviate it as PPT. And the actual pH is not super critical. You just do need to understand when phenolphthalein is in an acidic solution, or when it's lower, when the pH is lower, then it's going to be clear. As soon as it turns basic, then it turns pink. I mean, it's over 8. You should not think that it is pink in an acid. The other indicator that we used in class is bromothymol blue. And this is a good one because it has a couple ranges. Like if it's below 6, it'll be yellow. If it's If it's in the small range right here, then it would be green, or if it's greater than this, it would be blue. So definitely, if it's blue, it's basic. It's most likely basic. And then it's hard to print in color here at school, but you should understand universal indicator changes like this. And actually, this is kind of true for almost all indicators. If it's red, it's probably an acid. So I use that little memory trick all the time. If it's blue for base, B, or violet, B, but B for blue, B for base. That's my little mnemonic device to help remember what color is this indicator in which pHs. So if it's red, it's likely an acid. If it's blue, it's probably a base. And you can see the gradual changes for universal on this little chart here. So that's all I have for you. Good luck on your test. If you have any questions, you can come see me.